So today we have easy problem. Given some number n, we want to find greatest common divisor for the sum of the odd numbers and sum of the even numbers. So the sum of the odd numbers is 1 plus 3 plus 5 plus 7 and so on up to n, and sum of the even numbers is 2 plus 4 plus 6 plus 8 up to n. And the greatest common divisor is the biggest number that can be used to divide it without the remainder. Okay, this is easy problem, and we can just do this calculation of the sum. We get sum odd and sum even, or even, I don't know. And then we just calculate the GCD is a recursive function AB. So if how you can remember it, just imagine in your head that you're doing A divided by B, and that means you have to check B is not 0. So if it is 0, just return A, then it's finish line. And the recursive call is the GCD, and you have to remember some mnemonic. I use just BAB, and this is a percent number like BAB. You have to remember that mnemonic, and you can always check yourself and just put some numbers like I don't know, 12 and 6 and check if it's correct. Okay, let's look at my solution. This is Kotlin version. Just use extra function, and I used lazy sum of step. And by the way, the greatest right border is upper bound is 2 times n to make exactly n numbers. Okay, but what amazed me is that when I looked at how some other guys solved this problem, and this solution is like interesting. Why it is just n? So instead of doing all this mathematics, you can just return the n itself is answer. Okay, why is that? And this is because we have some interesting properties like mathematical. If we sum these odd numbers 5, 1, 2, 3, 5, 7, 9, and so on, this sum equal n squared. This is it, and this can be proved with your formula for the sum of arithmetic sequence. It is like n times divided by 2, first a1 plus the last an, and then you just put this a1 is 1, an is for the odd numbers you have like n 2n plus 1 or 2n minus 1. I don't remember exactly how it is. And eventually you'd get this n squared by what's and by the way, another formula is for the even sequence 2, 4, 6, 8 up to 2n. and this equal n times n minus or n plus 1, I don't remember exactly. And basically we have a GCD of n squared and n plus 1, and this is like n times n, and this n times n plus 1, and we can see that n is the common divisor, but is it greatest? And it is greatest because the other part is consequent n plus 1, and their GCD is just 1, because they're consequent numbers, like 3, 4, they always have GCD of 1. Okay, this is a kind of mathematical proof, but let me show you what else I discovered. Like interesting way to prove that when you have this odd sequence sum, it is n squared. Imagine you have 1, and 1 is just this cell. The square is 1, and when you add in this 3, you're taking this 3 ones around this one, like one box, and you have like corner of this 3 cells. So this is 1 and this is 3. Okay, and same for the 5, like 5 cells, 1, 1, 1 to the top, and 1, 1 to the right border, and you have this next. Like you grow this square, and the sum of these numbers would be actually equal this square. So this is square because it has height of n and the width of n, so the square equals n squared. And basically this is the sum of these numbers, equals 1 plus 3 plus 5 and so on. Okay, this is like geometry proof, but what about the other sequence, like 2 plus 4 plus 6 plus 8 and so on? So instead of doing it from scratch, let's start from this already built for the odd numbers and try to expand it to the even numbers. So we expanded it to the left. Notice this box of 1. We expanded it to is another one to make it 2, like we did it with 2. And we can grow and expand the next. So 3 expanded exactly into 1 plus 1 cell, and we expanded it into left column of the same square, and we get this rectangle that has a width of n and plus 1, because we have another column. This is the width equals n plus 1, and the height stays the same, and that means the area is n, this is height times n plus 1. So this is how you make it the geometry proof. Now what about proof of the GCD? GCD is the areas that we can split the common area. So if we have GCD of n, so this n is GCD, we can split it like this into vertical columns, and we see that we have perfectly split both figures, and the remainder of the first one is n, and from the second one is n plus 1. And that means that we cannot split it into bigger sub areas. Okay, that's it for today.